Betelgeuse, a titanic red star situated at the external scopes of our grandiose area, is a wonder. If it were placed where the Sun is, its size would stretch out to the orbit of Jupiter. This tremendous, erratic giant is poised for a blast of unfathomable proportions. Set yourself up for an event of cosmic importance. Betelgeuse, the red supergiant star on the fringe of our solar system, is sending disturbing signals across the vast field of space. Astronomers have revealed something unsettling about this massive star using the James Webb Space Telescope. Renowned scientist Brian Cox has issued a warning. The pressing question is, are we on the verge of witnessing a colossal explosion that will forever alter the night sky? The mystery of Betelgeuse lies within the boundless expanse of the universe. Stars are born, live, and die in extraordinary ways. Recently, one star has attracted both the attention and concern of astronomers and the public. Betelgeuse, a red supergiant star in the constellation Orion. It is colossal and ancient, with its distinct reddish tint and fluctuating brightness long enchanting observers. Recent developments have heightened interest in this massive entity. As we delve deeper into Betelgeuse, we may be approaching a critical moment in its life cycle. But what do these changes signify? Are we witnessing the early stages of an event of incredible scale? Betelgeuse's tremendous size and its life cycle are key elements in understanding its significance. This star is roughly 1,000 times the size of our Sun, making its magnitude nearly incomprehensible. Imagine a star so massive that, if it replaced the Sun, its surface would extend beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars. This immense size not only demonstrates Betelgeuse's exceptional scale but also reveals its current position in the celestial life cycle. As a red supergiant, Betelgeuse is nearing its dramatic end, expanding and cooling after depleting its hydrogen fuel and fusing helium. Betelgeuse is estimated to be between 8 and 8.5 million years old. Although this is relatively young by human standards, it is ancient in cosmic terms. Over millions of years, Betelgeuse has undergone dramatic changes, evolving from a hot blue star into the red giant we observe today. It is now in the final stage of its life as a red supergiant. Stars like Betelgeuse experience significant changes over their lifetimes due to the continuous forces of nuclear fusion and gravity. A key feature of Betelgeuse's current stage is its reddish color. This color arises from its cooler surface temperature compared to stars like our Sun. The Sun's surface temperature is around 5,500 K, while Betelgeuse's surface temperature is much cooler, around 3,500 K. This cooler temperature causes Betelgeuse to emit light at wavelengths that give it a red appearance, reflecting the ongoing processes within the star's vast gaseous structure. The fact that Betelgeuse's color has shifted over time adds another layer of intrigue. Historical records, including those from Roman and Chinese civilizations, suggest that Betelgeuse was yellow as recently as 2,000 years ago. By the 9th century, Arabic astronomers began noting its red hue. This change in color over the centuries signifies the star's evolution. A fascinating aspect of Betelgeuse is its fluctuating brightness. It is a semi-regular variable star, meaning its luminosity shifts periodically. These cycles of dimming and brightening have fascinated astronomers for centuries. Typically, Betelgeuse undergoes multi-day cycles and longer 5-year cycles. As early as 1836, Sir John Herschel recorded these variations, and Native American oral traditions may go back even further. However, what makes Betelgeuse particularly puzzling is the unpredictability of these brightness changes. Unlike many stars that exhibit predictable fluctuations, Betelgeuse sometimes deviates from this pattern, suggesting complex and not fully understood processes within its massive structure. In recent years, astronomers were stunned by a sudden and dramatic change in Betelgeuse's appearance. This unprecedented dimming event sparked various theories. Known as the Great Dimming, it occurred in late 2019 when Betelgeuse, one of the brightest stars in the night sky and a prominent feature of the Orion constellation, began to fade unexpectedly. The dimming happened so rapidly that Betelgeuse's light was decreasing at a rate of 0.01 magnitudes per day. By February 2020, the star was at its dimmest. Remarkably, Betelgeuse, which is typically visible to the naked eye even in areas with significant light pollution, became faint, and even casual observers noticed the difference. The mystery of the time delay complicates our understanding of Betelgeuse's behavior. Light from the star takes about 725 years to reach Earth. Therefore, when we observe Betelgeuse, we see it as it appeared centuries ago, not as it is now. This delay makes it challenging to predict and monitor rapid changes in its behavior. Andrea Dupree, the head of the Center for Astrophysics at Harvard and Smithsonian, and her team closely followed Betelgeuse's cosmic activity. As part of a 3-year study to observe changes in the star's outer atmosphere, they used the Hubble Space Telescope to study the star, providing new insights into the nature of variable stars. Variable stars like Betelgeuse expand and contract continually, causing fluctuations in their brightness. Thanks to Hubble's sensitivity to ultraviolet light, astronomers gained a deeper understanding of Betelgeuse's complex behavior. The Great Dimming Event in 2019 to 2020 captured the world's imagination and triggered a flood of research. While some theorized that Betelgeuse might be on the brink of a supernova, further investigations revealed a different explanation. Astronomers discovered that the dimming was likely caused by a massive ejection of material from the star's outer layers. This ejection formed a cloud of dust that temporarily obscured Betelgeuse's light when viewed from Earth. This phenomenon, while extraordinary, is not entirely unexpected for a star in its late stages of life. As a red supergiant, Betelgeuse is prone to such violent outbursts. These events shed light on the dynamic processes occurring within the star as it inches closer to its ultimate fate, a spectacular supernova explosion. A supernova is the dramatic death of a massive star, resulting from the collapse of its core. When Betelgeuse finally goes supernova, it will release an enormous amount of energy, briefly outshining entire galaxies. The explosion will produce heavy elements such as gold and uranium, which will be scattered across the cosmos, contributing to the formation of new stars and planets. One of the most fascinating aspects of Betelgeuse's eventual supernova is the potential impact on Earth. While the explosion will be an awe-inspiring celestial event, it poses no direct threat to our planet due to Betelgeuse's distance of approximately 642 light-years. However, the light from the supernova will be so bright that it may be visible even during the daytime for weeks, or even months, transforming the night sky and captivating observers worldwide. Astronomers are keenly aware that predicting exactly when Betelgeuse will explode is nearly impossible. The star's behavior is complex, and its internal processes remain only partially understood. However, studies of its fluctuating brightness, temperature, and recent dimming events provide valuable clues about its current state. The James Webb Space Telescope, along with other cutting-edge observatories, continues to monitor Betelgeuse, offering new insights into its evolving story. Betelgeuse's journey toward its eventual demise is a reminder of the life cycles of stars and the interconnectedness of the universe. Stars like Betelgeuse play a critical role in the cosmic ecosystem, creating and dispersing elements that make life on Earth, and beyond, possible. As scientists unravel the mysteries of this magnificent star, they not only deepen our understanding of the cosmos but also remind us of the fleeting yet enduring beauty of the universe. Cosmologists had the option to observe the layers above Betelgeuse's surface warmed by the star's whirling convection cells. Spectroscopic information accumulated from Hubble in 2019 and 2020 uncovered huge changes in Betelgeuse's upper atmosphere. The spectra primarily showed magnesium, indicating that material was being catapulted from the star's surface into space at speeds of around 200,000 miles per hour. This emission and mass loss continued for several months, with material traveling thousands of miles from the star, creating a dust cloud that darkened Betelgeuse's light. Dupree and her team discovered that the amount of material ejected from Betelgeuse's southern hemisphere was twice as much as expected. While it's typical for stars to lose mass over time, Betelgeuse's mass loss was occurring at a much faster rate than the Sun's. Cosmologists speculated whether this event could signal the looming supernova of Betelgeuse. Given the star's size and the massive ejection of material, along with the dimming, researchers wondered if this could be an early indication of a catastrophic end. At 725 light-years away, any explosion from Betelgeuse would be visible from Earth, presenting a unique opportunity to study a supernova up close. The question remains, what does this dimming mean for Betelgeuse's future? Is it the precursor to an inevitable supernova, or is it just a temporary event in the star's long and complex life? Several theories have been proposed to explain the rapid dimming. One popular hypothesis suggests that this could be a starting phase in the supernova process, a sign that Betelgeuse is nearing the end of its life. Another theory proposes that dust, possibly ejected by the star itself, could be blocking our view. Red supergiants like Betelgeuse often shed material, which can gather into a dust cloud thick enough to obscure the star's light. A third hypothesis suggests that changes in the star's photosphere, its visible outer layer, could be responsible for the dimming. Spectroscopic examinations showed that Betelgeuse's effective temperature had decreased by at least 170 K during the dimming, supporting the idea of massive changes on its surface. The Hubble Space Telescope played a crucial role in unraveling the mystery. Its observations showed that the dimming was likely due to a large amount of hot material being expelled into space. This material formed a dust cloud, blocking light from about a quarter of the star's surface. The dust cloud was made of plasma that traveled from Betelgeuse's hot atmosphere to cooler outer layers, forming dust grains that obstructed light. The impact of this ejected material was clearly evident from Hubble's ultraviolet spectroscopic data, starting in January 2019. These observations provided vital information about the material moving through the star's atmosphere well before the dimming occurred. Several ground-based telescopes also observed the decrease in brightness, beginning in December 2019, which Hubble confirmed and expanded upon with further details. The realization that Betelgeuse was losing material at a faster rate than previously thought has significant implications for our understanding of stellar evolution, especially for red supergiants. It's important to note that Betelgeuse is not the only star undergoing such dramatic changes. Other historical supernovae such as SN 1054 and SN 1987A have provided valuable insights into the death of stars and the creation of new elements. If Betelgeuse eventually becomes a supernova, it would offer a spectacular light show visible from Earth. The explosion would be brighter than the Moon and might even be seen during the day. This event would provide a rare opportunity to study the final stages of a massive star's life and the distribution of heavy elements across the universe. However, the distance between Betelgeuse and Earth ensures that any such explosion would not directly harm us. In conclusion, the ongoing observations of Betelgeuse's potential transformation will continue to expand our understanding of stellar evolution and cosmic phenomena. Red supergiants like Betelgeuse play a crucial role in the life cycle of stars, and their explosive deaths contribute to the formation of heavy elements essential for the creation of planets and life. Studying stars like Betelgeuse offers valuable insights into the final stages of stellar development and the processes that shape our universe. Betelgeuse's recent behavior has spurred discussions across the scientific community about the broader implications for understanding the life cycle of massive stars. Observing such events in real time provides astronomers with invaluable data about the mechanisms driving mass loss, dust production, and the processes leading up to a supernova. One of the key areas of interest is the connection between the star's internal dynamics and the visible changes on its surface. Researchers believe that the convective cells within red supergiants like Betelgeuse play a critical role in these phenomena. These cells, which transport heat and material from the star's core to its outer layers, can create pulsations and irregularities that contribute to the ejection of material into space. Moreover, the study of Betelgeuse may shed light on the production of heavy elements such as carbon, oxygen, and iron, which are crucial for the formation of planets and life. The dust clouds and ejected material from stars like Betelgeuse serve as the raw materials for new star systems, demonstrating the cyclical nature of the universe. Astronomers are also keen to determine the timeline for Betelgeuse's potential supernova. While it is unlikely to happen in our lifetimes, the exact timing remains uncertain. Current models suggest that the star has tens of thousands of years left before it reaches its explosive end. However, the recent dimming event has challenged these predictions, suggesting that we may not fully understand the final stages of massive stellar evolution. If Betelgeuse does go supernova, it would provide a rare observational opportunity. The light emitted from the explosion would allow scientists to study the core collapse process in unprecedented detail, offering insights into the physics of supernovae and the formation of neutron stars or black holes. Ground-based observatories and space telescopes, such as the James Webb Space Telescope, would work in tandem to capture every moment of this cosmic event. In the meantime, continuous monitoring of Betelgeuse remains a priority. Advancements in technology such as adaptive optics and high-resolution spectroscopy will enable astronomers to observe the star with greater precision. Collaborative efforts between observatories worldwide will ensure that no detail is missed as Betelgeuse continues to evolve. The fascination with Betelgeuse extends beyond scientific inquiry. Its dramatic changes have captured the imagination of the public, highlighting the dynamic and ever-changing nature of the universe. As one of the brightest and most prominent stars in the night sky, Betelgeuse serves as a reminder of the vastness and complexity of the cosmos. Ultimately, the study of stars like Betelgeuse not only deepens our understanding of stellar evolution but also underscores humanity's enduring curiosity about the universe and our place within it. Whether or not the recent dimming marks the beginning of the end for this iconic star, its story will continue to inspire astronomers and stargazers alike for generations to come.